motion under gravity. So motion under gravity I have discussed, and okay, so today we will discuss basically the graphs. And in the last classes we have discussed the motion. We have discussed the straight line motion. You can see here we have just discussed the straight line motion, means a body or a person is moving on a straight line. Okay. Then the analysis of this motion we have done with the help of the equations. With the help of the equations, okay. After that, I have discussed the motion under gravity. So the motion under gravity is also a straight line motion. In this case, in this case, a body is dropped from some height. So basically, this is a straight line motion. If a body is thrown in upward direction, the body will move in a straight line. Okay. So all these things we have interpreted it with the help of the equations. Now we will discuss with the graphs. With the graphs. So uh, for that, we will discuss the graphical representation of motion along a straight line. Now we will discuss the graphs. So Ryan, what is this? This is your
Sir, yes, my syllabus for the test.
okay for the
test that's coming, the exam.
okay. When this exam will be?
28th.
28.
Hmm.
Hmm. Okay, so after this graph, I will start the forces. Okay,
Yeah, okay.
We will discuss the forces after this graph, because you should know the graphs also. Okay, so after this graph, we will discuss that you have told me and your syllabus. Okay, so basically in this graph, in kinematics that we are studying, we are studying motion in a straight line. Okay, motion in a straight line. uh, so we will discuss basically three types of graph. First will be the displacement time graph. displacement time graph. Another we will discuss the velocity time graph. Velocity time. And number third, we will discuss the acceleration time graph. Acceleration time graph. So, Rayyan, do you have any PDF of your syllabus book? Means not syllabus book, of your book that you are studying in your school?
No, but I gave you the name because there was no PDF. I
There is no
gave you the
PDF.
name because I didn't have a PDF.
Okay. Okay, so basically in this, what we are going to do, we will take two axes. We will take two axes. You know what are the axes? X-axis and Y-axis?
Yeah.
This vertical line is a y-axis. This horizontal line is x-axis. Y-axis. This is your x-axis. Okay, so what we will do now? When we will draw these graphs of displacement time, velocity time, acceleration time. So time we will take on x-axis. Time we will take on x-axis, and other quantities like displacement, like velocity, like acceleration, we will take on y-axis. Okay, we will take on y-axis. Displacement, and accordingly there will be the graphs. So first graph is like this. Suppose Rayyan, you were absent in the last class. Why?
Yeah, I was out and we had people at the
Okay,
house.
okay, no problem. So this is your x-axis, this is your y-axis. Basically, uh, let me tell you, this is your origin. What is this? Origin. Origin means the starting point. Okay, origin means the starting point. So this side of the origin is positive x-axis, plus positive x-axis, and this side of the origin is negative x-axis. Upside of the origin is a positive y-axis, and downside of the origin is a negative y-axis. Ryan, got it?
Yeah,
So
sir.
basically, I am just taking the positive y-axis and positive x-axis this time. For this graph, I am taking the positive y-axis and positive z-axis. Suppose the graph is like this. Suppose the graph is like this. Uh, the graph is started from this point, and this is the graph. This yellow color thing is representing the graph. Yellow color thing. And this is a graph between the displacement. Displacement is, I will represent it with S. What we are discussing basically, displacement time graph. Displacement time graph. So on y-axis, I will take the displacement, and on x-axis, we will take the time. So displacement is on y-axis and time on x-axis. Finally, the graph is this. Finally, the graph is this. So you can see that if you are moving in this direction, if you are moving in this direction means time is increasing. Okay, suppose here is time at this point, time is equal to 0 second. At this point time is equal to 1 second. At this point time is equal to 2 second. Okay, at 0 second the displacement is 0. Okay, you can see at time is equal to 0, the displacement is 0. At time is equal to 1, the displacement is 1. Time is equal to 2, the displacement is 2. So what is the meaning of that? Displacement is not changing. Displacement is not changing with time. So we can say from this graph, we can conclude that body is at rest. Body is not in motion because the displacement is not changing with time. Is it or not?
Yeah.
If suppose this is a pen, this pen is here. This pen is not moving like this, like this. This is not moving.
Yeah.
Means the displacement of the pen is not changing with time, but time is changing. 1 second, 2 second, but this
Yeah.
pen is on the original position. Okay, so here displacement not changing with time. With time, so the body is at rest. So the body is at rest. This is the first graph. Okay, second graph. Second graph. On y-axis, I am taking the displacement. On x-axis, I am taking the time. And suppose the graph is like this time. Like this. Okay, so now here at t is equal to 0, displacement is this. Suppose this is s1 displacement. And at t is equal to 1, this is the displacement. Again, the displacement is s1. At t is equal to 2, again the displacement is s1. At t is equal to 3, again the displacement is s1. Means what is the meaning? What is the meaning?
The time increases, but the displacement is staying the same.
Okay, very good. What this means that initially the body has some displacement. Initially the body has some displacement, but after some time the body becomes at rest. Okay, initially the body have some displacement, but after some time the body at rest. So what is the mean here in this graph? In this graph, what is happening? Initially also t is equal to 0 means na, whenever t is equal to 0 I am writing. So you will say initially. Initially. So here at t is equal to 0, displacement is 0. Means initially also the displacement is 0. And with time the displacement is not changing. Means initially the body is at rest here. But here this body have covered some distance, some displacement initially. So we can write at t is equal to 0, displacement I will represent displacement with s. Displacement of the body is s1. After that body becomes after that body is at rest. What is the
Hmm.
meaning of that? Suppose this is the pen. Uh, for some time, this pen has moved from here to here, from here to here. Now time is changing, but the position of this pen is not changing. Means initially this pen has covered some distance, but after some time, this pen will be at rest. Okay, this pen will be at rest, or you can say attain the condition of rest. Okay. Now
Hmm.
third graph. Third graph. So here we have the displacement on y-axis. On x-axis we have the time. So suppose the graph is like this. Uh, this is very interesting case. Suppose the graph is like this. Suppose the graph is like this, and here na, suppose this is t is equal to 0. T is equal to 0 means initially. I have told you t is equal to 0 means initially. So initially there is no displacement. Initially there is no displacement means initially the body is at rest. Now after a time, suppose at this time, this will be the displacement. For this time t is equal to 0, suppose this is t is equal to 1. This will be suppose the displacement s1. For this time, suppose after 2 seconds, suppose the displacement becomes s2. After 2 seconds, the displacement becomes s2. So now here for 0 to 1, 1 to 2, for 0 to 1, 1 to 2, this s1 and this s1 minus s2 will be equal. What I want to say now? What I want to say, this body is covering equal displacement in equal interval of time. What is the meaning? Suppose from 0 to 2 second, 2 to 4 second, 4 to 6 second. Suppose 0 to 2 second, it has covered 2 meter. For 2 to 4 second, it covered 2 meter. Okay. For 4 to 6 second, again covered 6 second. Again covered 2 meter. So in first 2 second covered 2 meter. Second next 2 second covered 2 meter. Next 2 seconds covered 2 meter. So what is the meaning? In equal interval of time, the body is covering the equal displacement. So this is the case here. So from here to here, the time is this. From here to here, this is the time, and this is the displacement covered by the body. This is the displacement covered by the body. This is s1, and suppose this is the time of 1 second. Okay, and this is the, for this time the body has covered this displacement. For this time the body has covered this displacement. This displacement is s2. This displacement is s2, and this is 1 second. This length will also 1 because this is 2. So this also be the 1 second. So in 1 second, the body will again cover the displacement s2 minus s1. But this s2 minus s1 will be equal to s1. So we can say that the body covers equal displacement in equal interval of time, in equal interval of time. So if a graph is passing, na, if you can say that. And just a minute. I have told you, if a body covers equal displacement in equal interval of time, means the body is moving with constant velocity. Means the body moves with constant velocity. Means there is no change in the direction of the velocity, there is no change in the magnitude of the velocity. For example, a body is moving along the straight line with a speed of 5 meter per second along east direction. Means this body will continue to move in a east direction. Okay, so this graph is representing the body is moving with constant velocity. This graph is representing the body is moving with constant velocity. So if the graph is straight line and that straight line is passing from the origin, so you can say the body is covering the equal displacement in equal interval of time, means you can say the body moves with constant velocity. Okay.
Yeah, okay.
Okay, so you can first take the screenshot, then next things we will discuss after. Take the screenshot first.
Okay, sir, is there any way you can send it to me? Because this like
Notes.
I don't have enough storage.
So I know. Okay, so at what thing, means on your number, or where should
Like,
I send you?
can you send it by email? Is that possible?
Email? Of course, I can send you by email.
Okay, I'll type in my school email. Can you send it on that?
No. You should. You have a number of official number of Learnivio.
Of what?
Because you can send them the email address, and I will send them the notes. They will send you the notes on your email.
Oh, okay. So like
Okay,
the
that
people
will be fun.
that send me the link, them,
Hmm?
the number that ends with 84958. Okay,
I
so
think.
I just send them my email.
Oh, I think they have. They already have your numbers or your parents' number.
Yeah, they have my number.
Okay, no problem. So I will send them. They will send you. No problem.
Okay.
Okay. So basically, have you understood now this
Yeah.
thing, and this thing?
Hmm.
Hmm. So there is one more graph. If the graph is a straight line, if a graph is a straight line, then you will say the body is moving with constant velocity. The body is moving with constant velocity. The graph is straight line. What then you will say the body is moving with constant velocity. Okay, so next graph. So Ziad, sorry, Rayyan, uh,
Yeah.
the your syllabus. I have seen your syllabus. So when we will have the next class?
Saturday, I think.
Saturday. So will you available on Saturday or will you absent?
I think I'll be here.
You will be absent.
No, I think I'll be here. I think I can join.
Yeah,
If I'm
because
not, I'll
na
let you know.
yeah.
Yeah.
Please available. I will suggest you available on that day, because from that day we will start your preparation of your that test. Okay.
Okay.
So if you will absent, then it will be the loss now.
Yeah.
And don't absent until and unless the work is very very important. Okay.
Yeah.
Don't compromise with your studies. uh, so next graph I will discuss. Otherwise, I want to tell you one thing now. When we go to some cinema hall to watch a movie na, so we always want to watch the movie from the starting,
Mm.
not from the uh, 50 seconds later, 50 minutes later, and like that. This is
Mm.
the case with the subject that we are discussing. This is a subject when you will study this in a proper way from starting. Like there are a number of steps. Like we move to the stairs now. One stairs, then other, then other, then other na.
Yeah.
So
Uh,
we cannot directly reach at that level. We have to cross one stair, then another, then another. This is the case with the study also. Means we have to study step by steps, and those steps are fixed. Okay. So I'm not starting that the forces and all that, because before the forces you should know this, but from the next class uh, I will start that. I know what is the gravitational, electrostatic force and all these things. We will discuss all these things, no problem. Okay. So means in your school this kinematics is completed. This chapter is completed. Means this displacement and velocity.
yeah. Yeah.
Okay. And okay. So next graph. Next graph is like this. Suppose the graph is like this. This is the graph. Okay. So this is the graph between the displacement and time. This is the graph. So this is the point at t is equal to 0. This is the initial point. This is initial condition. So initially there is some displacement. Suppose s1. So initially there is some displacement, body covered.
Mm.
Okay. So means initially the body have some displacement, or you can write the body covered some displacement. What I have told you, for means at t is equal to 0, the displacement is s1. Okay. Means initially body has already covered some displacement, and after that the graph is a straight line. What is the meaning of straight line graph? Constant velocity. After that the body is moving with constant velocity.
Mm.
After that the body moving with constant velocity. Body is moving with constant velocity. Okay. So if the graph is a straight line, okay, if the graph is a straight line, then we can, a straight line like this. So we can say the body has the uniform velocity or constant velocity. Okay, the body has uniform or constant velocity, and if at t is equal to 0, if at t is equal to 0, uh, there is some initial displacement. Means we will say initially the body has covered some initial displacement, and if this the graph is like this, if the graph is like this, then you will say uh, the initially the body is at rest, means initially the body has not covered some the displacement. Means we can say initial velocity of the body is zero, and after that the body started moving with constant velocity. After that the body started moving with constant velocity. Okay.
Okay.
Okay, so there is another graph here. This graph is all between displacement and time graph. And if graph is suppose like this, graph is like this. So in this case, and I will tell you one more thing about the graph. In this case, see here, at this point at t is equal to 0, there is some displacement. Suppose this is s1, and finally at some time t, this is the finally, and this is the initial condition. So what we can say, with time the displacement is decreasing. Suppose at this time the displacement will be this. Okay, at this time the displacement will be this. Okay, so means from here to here, means the displacement is decreasing with time. So what you can say, displacement is decreasing with time. With time there is some initial displacement, because at t is equal to 0 there is some initial displacement. There is some initial displacement, and finally the displacement becomes 0. And finally why I am saying finally the displacement becomes 0, because see here, this is the final condition. Here displacement is 0 or something else. Finally the this beta, are you getting, Rayyan?
Yeah.
See, at t is equal to 0 na, this is the displacement. At some time, after some time t, finally there is no display, there is means the displacement becomes 0. Okay. And this graph is a straight line graph. This graph is
Yeah.
a straight line graph now. So you can
Yeah.
say the body is moving with uniform velocity. The body is moving with uniform velocity. Okay.
Okay.
And I want to tell you one more thing about the graph. Mm, about the graph. Okay. What I will do, suppose you are just drawing a line which is parallel to which is parallel to this time axis. This line and this line are parallel, and suppose this is some angle. This is some, what is this angle? This is angle theta. This is some angle theta. So can you tell me this angle will be greater than 90° or less than 90°? I am not asking the exact value of theta. I am just asking, will this angle theta will be greater than 90 or less than 90?
Uh,
You can just try.
Less than 90, yeah. That's below.
Very good. Less than 90. Theta is less than 90. So
Mm.
theta is less than 90. So I can write like this. Theta angle is less than 90 degree. Remember, if your theta is less than 90 degree, then velocity will be positive. Then velocity will be positive. Okay, I am not going in the detail. I want to just tell you this thing because that will be out of your syllabus. If I will tell you about the slope and all that. Do you know? Have you heard about the slope? SLOP slope.
Yeah, yeah.
What is that? Okay, you can tell me if you then we will discuss that slope. That slope is a very interesting thing for the study of the graph.
Yeah, the slope is like the line, I don't know how to explain it, but like on a graph, the line,
Mm-hmm.
like you have to find the slope. So
Mm-hmm.
like use y equals mx plus c,
Yeah,
and
yeah,
you
yeah.
find the
Means
slope.
you know. Means you know. Okay, so
Yeah.
now we will discuss. Now we will discuss. Okay, actually, what happens now? What happens
Mm,
now? I am explaining the whole thing. Okay, here I actually I
mm.
think I should tell you. You know this thing, so that is why I am explaining. Hmm. Suppose this is the x-axis. This is your y-axis, and
Mm,
suppose this is the graph. This is some graph, and this graph is like this. This graph is like this. Okay, and this angle is theta. This angle is theta. If this is
mm.
the case, I am telling you the slope. Have your teacher told you about the slope?
Yeah, I think.
Okay, no problem. So that is why I am telling now. So at this point, at this point, this is the initial condition. This is the initial condition. Okay. So what I am doing now,
Mm,
I want to find the slope, and I will tell you what is the slope. Now join this. Okay. Suppose here the coordinate is 0 comma 0. The coordinate of this point is 0 comma 0 because this is the starting point. So
mm,
here the coordinate is x comma 0. Okay, here coordinate is x comma 0. Okay, and this is basically x comma y coordinate. This is basically x comma y coordinate. So this distance, na, this distance, there is no need of this. This distance will be your y distance, and this distance will be your x distance. This distance. So this distance will be your x distance, and if this distance is x, these both lines are parallel and equal. So this distance will also be x. This distance will also be x.
mm.
So what I want to say, so this becomes a triangle, na, this thing. If I am removing this, then we can say this is a right angle triangle. This is a triangle.
Mm.
Hmm. So do you know Pythagoras theorem?
Yeah.
Okay, good. Okay, so Do you know trigonometric function, trigonometric identities like sine, cos, tan?
Yeah, I think.
Okay, so now for the slope, now what we do now? We find tan theta. Tan theta will be the slope of the graph, and this tan theta is given by perpendicular of the triangle, base of the triangle, or you can say height of the triangle divided by the base of the triangle. That will be y by x. That will be y by x. This will be the slope. So if someone is asking slope, then you can say this is tan theta. Okay, tan theta will be the slope of the graph. So basically, na here, uh, here why I am taking why I was saying this, when theta is less than 90, velocity will be positive, because for this graph, na, for this graph, if you calculate the slope, then slope you will get displacement divided by time. Okay, you will get some value of displacement, some value of time. What is displacement divided by time? That is velocity, and this
Mm,
is slope, and slope is given by tan theta, and
yeah.
theta is less than 90. So if theta is less than 90, then tan theta will be greater than 0. So slope is greater than 0 and velocity is the slope. So that is why I am saying velocity is greater than 0. Okay. So now for this graph, now for this graph, if I am taking this graph, so if I will talk about the slope of this graph, suppose here I am just, this is the graph. Huh? If I want to find the slope, so this angle, suppose this angle is theta. So can you tell me this theta will be greater than 90 degree or less than 90 degree? Just you can think. Okay, no problem. This theta is basically greater than the 90. Why greater than 90? Because here, see here, uh, if you will draw a 90 degree from this, means perpendicular from this will be that. This will be this will be the, means this angle I am saying. This angle will be 90 degree angle. This angle
Mm,
will be 90 degree angle, and this theta is greater na than 90.
mm,
If this is the case, if this is the case, suppose this is theta. When you will draw the perpendicular like this, so this angle will be 90. So here theta is less than 90 degree, and in this case, your theta is greater than 90 degree.
mm,
Now, oh, your theta here is greater than 90, okay, and less than 180. Less than 180 means your theta is in between 90 and 180. If this is the case, na, if this is the case, so you can say that your tan theta will be less than 0. Less than 0 means tan negative. Less than 0 means negative. And I have told you slope of the graph is equal to tan theta. So you can say slope will be negative. Is it or not?
yeah.
So slope of this graph is negative. Now what I have told you, when you will calculate the slope of this graph by different method, means slope is also given by displacement divided by time. Slope of displacement time graph is given by displacement divided by time. slope of this graph also given by displacement divided by time. Basically, this displacement divided by time can be derived with the help of this tan theta, but that I am not doing. Okay, this is SYT. This is the velocity. Displacement divided by time is velocity. Now, can we comment something about the velocity, whether the velocity will be positive or whether the velocity will be negative from this data? Here your slope is negative, and we know that slope is the velocity. So we can say for this kind of graph, the velocity will be negative.
Okay.
For this kind of graph, the velocity will be negative. Okay.
Okay.
So now one more case I will take. Two more cases I will take. Suppose we have a graph like this. This is your displacement. This is your time. This is your displacement. This is your time. So for this type of graph, this is not a straight line graph. Okay, this is not a straight line graph. For this type of graph, when you will see the, suppose this is the initial condition, t is equal to 0. This is some another condition. At some time the displacement will be this. At another time the displacement will be this. At another time the displacement will be this. So if the graph is in the form of curve, if the graph is a curve, or you can say if the graph is not a straight line, then you will say this graph significance that the body is moving, unequal displacement in equal interval of time. Body is moving unequal displacement with equal interval of time. So what is the meaning of this? If the body is covered the equal distance in equal interval of time, then we can say the velocity of the body is constant. If the body is covering unequal displacement with equal interval of time, then we can say the velocity of the body is variable. So here you can say velocity is variable, means velocity is changing with time. Velocity is variable. Variable means at different times there will be different velocity, means not constant. Velocity is not constant here. Velocity is not constant if the graph is like this. Okay. Rayyan, are you getting what I want to say?
Yes, sir, I am.
So this is the about the graphs. Okay. So if this is the condition, so here initially the body is at rest, and finally also the body is at rest, means body is at rest for all the time. Here initially the body has some displacement, and after this the body is, the displacement of the body is not changing, means the body becomes at rest. Okay, here the body is moving with constant velocity. Here the body is moving with constant velocity and initial displacement is 0. In this case body have some initial displacement, and after that it is moving with constant velocity. Here the body is moving with constant velocity because the graph is a straight line, but this velocity is negative. Okay, velocity is negative. This is the case for the upper graph. This is the case for the upper graph. For this graph I have written here, displacement is decreasing with time, there is some initial displacement, and then I have just told you the brief idea what is slope. Idea what is slope. So if this kind of graph, if you want to analyze this graph with slope, then also I have told you what you have to do. Okay, here this theta is with time axis, and this theta you have told me greater than 90 degree. So theta is between 90 to 180 degree, and for this the tan value will be negative, and slope of displacement time graph I have told you will be the velocity, and then you can say that the velocity is negative. Okay, velocity is negative. If this kind of graph will be there, this is kind of curve type of graph, not a straight line of graph, means in this graph you will find that the body will moving, the body is moving, or you can say body is covering unequal displacement with equal interval of time. What is the meaning? Means suppose this is some body A, uh, and this is moving like this. Suppose this is a person on bike, and this is moving A to B, B to C, C to D. For A to B, he has covered 20 meter. For B to C, he has covered 23 meter. For C to D, he has covered 85 meter. So, but time taken in going from A to B is 4 seconds. Time taken from B to C is again 4 seconds. Time taken from in going from C to D is again 4 seconds. If this will be the condition, if this will be the condition, then the velocity will be not constant. Velocity will be changing. You can just calculate. If you want to calculate the velocity in going from A to B, then what is the displacement? 20 by 4. Okay. And when you will calculate the velocity from B to C, it will be 23 by 4. Okay. And from C to D, 85 by 4. So you can say that velocity is increasing. Velocity is increasing means velocity is not constant. Velocity is changing, because this value is greater than this value, and this value is greater than this value. Okay. So now I want to discuss something that you have told me that we have to discuss your syllabus. So I want to ask, do you know what is the force? What is the force?
Yeah.
What is the definition?
Yeah.
Tell me.
It's like a push or pull, and
Push or
yeah, and it acts upon all objects, and it can change the shape of something, and it can move something while it's stationary.
Very good, very good, very good. Means what is force? Basically, force. What the force do? Suppose this is a pen, and I am applying some force. So due to this force, this body is moving. Means the position of the body is changing due to the force. So basically, force is something which cause the motion. Cause of the motion is force. Okay. So in the next class, we will discuss what are different types of forces, like gravitational force. Just I am telling what is gravitational force, giving some initial idea. Basically, gravitational force is invented by a scientist Newton. Have you heard about the Newton? Do you know the name Newton?
Yeah.
Yeah, Newton. Very good. Here also Newton is written in your syllabus. So Newton discovered that if you take two bodies, suppose this is one body, this is pen, and this is me. So he discovered that there is a force of attraction between this pen and me. That force is a gravitational force. That force is a gravitational force. Okay.
Yeah. Okay.
And Electromagnetic force means when there is a combination of electric field and magnetic field, then that force will be the electromagnetic force that we will discuss in the next class. And there are strong nuclear forces and weak nuclear forces. Strong nuclear forces, we will find these forces inside the. Do you know the what is atom? Do you know what is atom?
Yeah, yeah.
What is atom?
Everything is made of an atom, and it has a
Mm-hmm.
nucleus and electrons, protons, and neutrons around.
Mm-hmm.
That's what I know. I don't know how to explain it.
Yeah. So basically, inside the atom, uh, at the center there is a nucleus.
Yeah.
I want to tell you that. So inside the nucleus there are protons and neutrons. So protons
Correct.
are positively charged. Protons are
Yes.
positively charged. So in those positively charged protons, the force will be there, and that force will be the strong nuclear force. And weak nuclear force are something different. Okay, like van der Waals forces. Okay, we will discuss all the things. Uh, so around the nucleus, electron revolves.
Mm.
Around the nucleus, electron revolves. Na?
Yeah.
Yeah. So basically, the electron is negatively charged. Electron have negative charge, and proton has positive charge. And charge of the electron and proton is equal. We will see that. Okay.
Yeah.
So nature has made up of uh, the forces. There are many types of forces: gravitational force, nuclear force, electromagnetic force. Okay, and there are some other forces also, like friction force. Okay, other forces also are there. So okay, please don't skip the next class. Okay,
Mm.
and we will discuss the topics related to your syllabus. And please tell me the name of the book once again. Okay, so that
Mm.
uh, what is the name? Just tell me once more.
Uh.
Can you send the
Yeah.
picture of that to
Uh.
that official number of Learnivio? Means
Yeah. Okay.
one front photo. Please send me this time. Okay.
Yeah. Yeah. I'll send it right now.
After the class, do you have that number now?
Yeah, I have.
Okay, so I will send the notes, and you should send the cover of your book on that number. You can send photo of that. Okay.
Yeah, I did.
So fine. If you have any doubt, if you want to ask anything related to these graphs, then you can ask me.